Hi, my name is Kunal. I'm a customer engineer at Google Cloud. Welcome to the Application Modernization with GKE. Today we will learn how we can use GKE to adopt containers for our application, especially in production. And let GKE take care of all the work in the background so that we can focus on building great applications. In the past, do you remember when you got a new server? You would install operating system on it and then one by one install the various applications you needed, such as web server, maybe a database, Java runtime, maybe some web package software, etc. In many ways, it was similar to what you did on your personal computer, whether Windows, Mac, or whatever. If you wanted to get fancy and add another web server or database later for scaling, you would just buy another server. Each server had a purpose. The problem is that this wasted a lot of resource, took a lot of time to deploy, maintain, and scale, and it was not very portable. In addition, many times applications were built assuming a specific operating system and even hardware. Then virtual machine was invented by VMware. VMware popularized the idea that you could run multiple servers and operating systems on a single physical hardware using something called hypervisor. Now you can create VM images and deploy them fairly quickly, and this improved hardware utilization, deployment time, and portability. But there was a catch. With virtual machines, you are still bundling the application, dependency, and operating system together. Could there be a better solution to this? So came the containers. We raised the abstraction level one more time, this time by virtualizing the operating system. We package only our application and dependencies together. This is called a container. We run this anywhere that runs the Linux kernel. It is ultra portable, so you can go from your laptop to the cloud without needing to change or reboot anything. It starts very fast, so your app scales very fast. It is lightweight because it doesn't carry the full operating system. So it can be packed onto the underlying hardware, resulting in the best utilization. Startup and shutdown is no more than starting and stopping a process running inside the operating system. This is the right level of abstraction and is the next step in the evolution of managing code. Containers provide us with many benefits, such as immutable infrastructure, meaning we deploy a service or application each time a change occurs. Components are replaced rather than changed. Containers are also reusable. You can use the same container in dev, CI/CD, and production environment. You can attach to a container and understand various metrics for the workload by running debugging and debuggers inside it. Because containers are so small, they offer much faster deployment times. This is very important if you are building immutable infrastructure. Containers can also be stored in repositories that provide us with versioning capabilities, meaning the ability to easily go back and forth between different releases of our containers. Containers are portable. You can move containers from one system to another system quite easily. If it works in one place, it will also work in another place. This allows containers to be shareable as well. So we just looked at how containers are great, but as you start to deploy them in production, it brought us a new set of challenges. How do you manage a large set of containers working in your environment? How would you network them together? How would you scale them with load to make sure you are sending traffic to a container that is not already dead? How would you do health checks? How would you store data inside a container, given that containers can come and go at any time? How do you monitor everything together? How do you do things like access control that will give you a better security posture? All of these challenges come to us when we think of running containers at scale in production. Fortunately, we have a solution, and it is called Kubernetes. Kubernetes is an open source container orchestration system for automating container application deployment. It does scaling and management for you. It was originally designed by Google and is now maintained by the Cloud Native Computing Foundation, or CNCF. If you drill down, Kubernetes is really two things in my opinion. Number one, it's an abstraction over infrastructure. When you install Kubernetes, it handles the compute, networking, storage on behalf of your workload. This allows you to focus on your application and not worry about the underlying environment. And number two is Kubernetes is a set of declarative APIs to orchestrate your containers. One of the really nice features of Kubernetes is that it has built-in primitives to handle a lot of heavy lifting that goes into application management. With those declarative APIs, you define what you want and not how to create it, and there is a good amount of difference between it. Because it runs in a control loop to ensure that your current state of your cluster matches the desired state as specified in your configuration files. If something doesn't match, Kubernetes is smart enough to know what steps to take to bring them back in alignment. And this is quite powerful. So the question is, what will Kubernetes do? And we talked about it, a lot of things. And if we are to put it in precise terms, these are things like scheduling, deciding when and where your containers should run. It also keeps container running despite failures. It will scale them accordingly and do load balancing across them. It will do things like health checks. If a container is not healthy, it will not send traffic to that. It provides storage volumes that allows you to persist data. As I explained to you before, if containers come and go, you cannot store data inside container. There has to be a way to do that, and Kubernetes provides you that way. It also provides with identity and authorization, meaning it gives you a means to access, to do access control and security policies so that you can implement the best security postures for your application and keep security issues and other problems related to security away from your infrastructure. So why not just run Kubernetes yourself? Or why would you think about another layer on top of it? The problem is running Kubernetes on your own is hard. You have to take care of many important things, such as integrating with the underlying infrastructure provider. And this could be anything. This could be whether a cloud provider or even your local servers. You also have to integrate with things like load balancers and auto scaling technologies. You have to make sure that there is a way for clusters to keep running even in the case of failure. You'll have to update them. So there are a lot of work that you have to do in order to run a Kubernetes cluster in production. But we have a solution. What if Google Cloud can take care of all that for you? That is where Google Kubernetes Engine comes in. It provides a fully managed environment for Kubernetes that incorporates the best practices and provides an easy to use, a secure UI integration. Google will be responsible for keeping your clusters up and running. And best of all, it allows you to integrate with other Google Cloud services. GKE also gets you the best of Google Cloud features, such as booting a node in just 30 seconds, having access to a global load balancer with single IP address, and have a great performance even after millions of QPS. Ability to run it from all the regions that we support. There is a cost optimization angle attached to it as well. You can use preemptible virtual machines to cut down the cost of running clusters by using the spare capacity that we have in our data centers. You also have the option to scale your workloads in variety of ways, whether it is adding more containers or the nodes on which these containers run. To put it in other way, GKE is auto-managed Kubernetes. Think of it as you have Google's SRE team at your disposal. Your cluster gets auto upgraded, auto repaired. You have regional and high availability on the control plane side of things. It provides easy way to auto scale and provides the ability to auto provision nodes. So to summarize what we spoke about today is back in the day we had server, then came virtual machines and containers. Containers did bring in a lot of benefits, but containers also brought in a new set of challenges. And those challenges can be solved by using an orchestration layer called Kubernetes. But running Kubernetes on your own is very difficult. Enter GKE. It gives you a way to run Kubernetes workload with ease. GKE lets Google be your SRE and handle important things like scaling, health monitoring, and load balancing. I hope you will give GKE a try and you will like it. Thank you for your time.